Alright, now next is you're flying from E to F, you find that your position is 90 nautical miles outbound from E and 6 nautical miles right of required track. What is your tracker? So here you're flying from E to F. Now these kind of questions don't really pertain to track headings and stuff, so you can draw the track in whichever direction you want. It is E to F. As I told you, what is important here is whether you're left of track or right of track. The actual value of track doesn't really matter, right? And you're flying from E to F and you find that your position is 90 nautical miles outbound from E, 6 nautical miles to the right. So say for example, if this E has some kind of a DME facility, then if you take an arc here, that is, how much is it? It is 90 nautical miles. So now 90 nautical miles outbound from E, and if you are on track, you're supposed to be here, but unfortunately you drifted away because of the wind or because of poor navigation techniques. You drifted off, and you are now 6 nautical miles right of required track. So be very careful to place the aircraft at the actual site. So here you're right of track, which means somewhere here. And how much is that? 6 nautical miles.
Yeah.
To right. And the heading of the aircraft again does not really matter here. But just to place the aircraft, I need some kind of a heading, and then I will draw this particular track here. And what is this track? This is the track.
This is the TMG.
Made good, and this is going to be the actual track or the plan. So this is going to be the plan track, and measured from the plan track towards the track made good is what is called as track error. Right? It's important to understand that it is from the plan track towards track made good. Right? So this distance gone is 90 nautical miles. Remember, the distance gone is actually this distance here, but you can still take it as 90 because the difference is negligible. As this angle keeps on increasing, you will reach a point where you cannot take it like that. Remember, beyond 20 degrees, how that 1 in 60 broke down? The difference was becoming bigger and bigger, right? Yes. So how will you find the tracker angle or tracker here? Applying 1 in 60.
Its distance off, that is 6 nautical miles.
Distance off by distance gone into 60. So distance off is 6 nautical miles.
6 nautical miles. Distance gone is 90 nautical miles. Multiplied by 60.
Into 60. Yes.
So that gives me 4 degrees.
Right? 4 degrees, that's right. 4 degrees. Right? So basically it's going to be 2/3 of 6 nautical miles. Right? Because 60 is 2/3 of 90. Right? When 120 was one half of the double of 60, the degree was half of the original one. So similarly here it is 60 is 2/3 of 90, and therefore the degree is going to be 2/3 of 6 nautical miles, right? Which is 4 degrees. So the track is 4 degrees. The track is actually measured from plan track to track made good. Therefore, what is the track error here? It is 4 degrees to right. Track error is usually expressed in left to right, and drift is usually expressed in starboard and port. Alright? Yes, perfect. So this is question number 3. Question number 4. You're flying from G to H. You find that your position is 30 nautical miles outbound from G, 4 nautical miles left of track. What is your track error? You can answer very quickly. 30 nautical miles.
It's 8 degrees.
It's going to be double your distance off, right? It's 8 degrees because you had a higher track error that you went off by 4 nautical miles just by traveling 30. Right? Alright. Yes, let's do the next question. Question number 5. So I hope you're happy with question number 1, 2, 3 and 4.
Yeah.
Right? Yes. Did you copy this down or you're okay with it?
Yeah, yes. You are flying from J to K, which is the required track of 045 degrees true. So 045 degrees true, this is my planned track from J to K.
Yeah, so a track from J to K is a required track of 45 degrees to the. What is required track? Required track is your planned track, right? So your planned track is given as
45 degrees.
45 degrees, that is from J to K, right?
Yeah.
Now, that's true. You find that your position is 80 nautical miles outbound from J and 4 nautical miles left of required track. So let's draw this this track JK here, it's 45 degrees. If you follow the true direction system, then 45 degrees is somewhere in this direction, right? This being J and this being K. This is, what track is this? This is your planned track, and that is 45 degrees true, right? What is the distance from J given in the question? Remember, you have to particularly understand whether it is given 80 nautical miles from J or from K, or to K basically, right? It is 8 nautical miles from J, which means I'm taking an 8 nautical mile arc here. I can draw the arc here. This is 80 nautical miles. It is from J. So traveling 8 nautical miles, I told you, you can either measure this using any DMA distance, or if you're doing a VFR flight, since it's more concerning about VFR here, you can actually have these measurements on your chart, and you have time, ground mapping and stuffs by which you can understand when you cover 80 nautical miles with respect to chart or with respect to timing, right? Once you cover 80 nautical miles, you have a significant feature, and you find yourself 4 nautical miles left of required track. So say for example, if you have on your chart somehow marked the lake here or something, you're supposed to be exactly overhead the lake, but you find that you are now to the left of the required track, right? By 4 nautical miles, right? So at this point, when perpendicular to the lake, you find yourself left of required track by 4 nautical miles. So you understand that the aircraft in fact flew a track made good. That in turn resulted in a track error, right? So here the question is, you're asked to find out what is your track made good. So in addition to finding your track error, you have to also find track made good. So how will you find track made good? If you have the planned track, to find track made good, you need a connecting factor, which is the track error, right? It's just one step more to the previous kind of questions, right? So let's find your track error by applying 1 and 60. So what's the track error? Track error is equal to distance gone off,
distance off by distance gone.
Distance gone into 60, and that is, what's distance off?
Nautical miles divided by 80 nautical miles.
Divided by 80 nautical miles.
Multiplied by 60.
60. How much is that?
Giving me 3 degrees left.
It's going to be 3 degrees, and since your track made good is left of your planned track, it's going to be 3 degrees left. Remember, it is always measured from planned track to track made good. Now you're asked to find out track made good. Since your planned track is 45 degrees and the track made good is left of planned track, the track is going to reduce. The true track is going to reduce. Therefore, what is track made good or actual track is equal to?
It equals to 450 minus 3 degrees or 4042 degrees left.
That's right. So it's going to be 042 degrees. True. Right? Perfect. Alright, now question number 6. Are you copying this with me, or did you copy it?
Yeah, copy. You are flying from L to M, which is the required track of 220 degrees.
So required track is again your planned track. From L to M is 220 degrees. True. You find that your position is 45 nautical miles outbound from L and 3 nautical miles right of required track. So let's draw this track from L to M. So LM? Yes, question number 6, LM. Right. So how will you draw a track of 220? By referring to the true direction system. 220 is somewhere in this direction, right? This is L and this is M, and this is going to be your planned track. 220 degrees. True. You find that your position is 45 nautical miles outbound from L. So 45 nautical miles outbound, it is from L. So I take a compass, I draw a 45 nautical mile arc. And what about the off distance? It's 3 nautical miles right of required track. So where will you place it? Will you place north of it or south of it?
North of it.
Yeah, but it's 3 nautical miles to the right of the required track, which means it's going to be somewhere here. This is where, so you have some kind of a stadium, some kind of a building here, and you realize that now the building is to my left, which means I am to the right of the planned track. This will tell you that the aircraft followed not the planned track, but it drifted off and followed another track, which is what is called as actual track, or track made good. This is the planned track, and that kind of induces a track error. Straight. You're asked to find out what is the track made good here. So you follow the same procedure. Using 160, you can find the track error, and then using that from planned track, you can find track made good. Therefore, applying 160, track error is equal to distance
off by distance gone multiplied by 60
into 60. Right.
That is 3 nautical miles.
3 nautical miles
divided by 45 nautical miles.
That is 45 nautical miles into
multiplied by 60.
Into 60. That's going to be
4 degrees, right?
4 degrees. And now, since your track made good is to right of planned track, it is 4 degrees. Right. Therefore, what is track made good?
It's 2 to 4 degrees.
So basically, it's a planned track of 220 degrees.
4 degrees. It's going to increase since it's on the right side.
It's on right. It's going to increase clockwise. Very good. So 220 plus 4, that is going to be 2.
4 degrees equals to 2 to 4 degrees true.
224 degrees true. It's your track made good. All right. Yeah. Question number 7. You're flying from N to P, which is a required track of 315 degrees true. So now you're flying from N to P, so the required track given, therefore planned track is given as 315 degrees true. Now you find that your position is 40 nautical miles outbound from N, 6 nautical miles left of required track. What is your track made good? Right? You can find out.
It's 306 degrees true.
Yeah, so the planned track is 315, so it is somewhere in this direction. That is from N to P. It's a planned track of 315 degrees true. Right? Now, you find that your position is 40 nautical miles outbound from what? From N. So it's 40 nautical miles from N. And 6 nautical miles left of the required track. So it is 6 nautical miles. 6? Yes. Left. So left is basically south of it.
Yeah.
And that will give you an idea that the aircraft followed a different path, which is the track made good. This is the planned track, and that will build up a track error. The problem with the track error is the further you go away, the more the distance off is going to be. So the earlier you correct it, the better. Right? Yes. Now, 6 nautical miles left of required track is right there. What is your track made good? So basically, your planned track is 315, 6 nautical miles over 40 nautical mile distance. So we can find track error first, and that is applying 160. Track error is distance off by distance gone into 60. What is distance off?
Distance of is 6 nautical miles
By distance gone
divided by 40 nautical miles divided by 60
into 60. Right?
It's giving 9 degrees.
9 degrees. And since your track made good is to the left of the planned track, it's 9 degrees left, and therefore your true heading is actually, true track is going to actually reduce. Right? So it's 315. What is the track made good? Track made good is equal to 315 degrees
5 minus 9.
minus 9 degrees. That is 3.
That is 306 degrees true.
True. So it's going to be 306 degrees is your track made good. Very, very simple question, but this will serve to be the basis or the basic of 160. So you should know, at least this so much should be pretty clear to you on how to do it. Right?